When we look at a collection of data, called a distribution, we're looking for a story. To tell that story completely, we need to talk about three main things. First, the shape. What does the data look like visually? Second, the center. What's the single typical value? And third, the spread. How much do the values vary from each other? These three properties give us a full summary of the data. The easiest way to see a distribution shape is with a dot plot. Imagine we collected data on how many hours students spent reading last week. A dot plot would put every student's answer as a dot above a number line. If you see most of the dots piled up over the number 3 and only a few dots over the number 8, the dot plot instantly shows you how the data is spread out. When describing the shape, the first thing to look for is symmetry. A symmetric distribution looks balanced. If you folded the graph in half, one side would mostly mirror the other. Think of a perfect bell shape. When a distribution is symmetric, the best news is that the mean and the median will usually be the exact same number, or very close. The opposite of symmetric is skewed. This happens when most of the data is piled up on one side and the other side trails off with just a few data points. That's the tail. If the tail points toward the larger numbers, it's skewed right. If the tail points toward the smaller numbers, it's skewed left. Skewness is important because it tells you the average is being pulled by those numbers in the tail. Other features of shape include clusters and gaps. A cluster is exactly what it sounds like, a group of data points gathered closely together. Clusters show the most frequent or popular answers. A gap is just an empty space where there are no data points. Recognizing clusters and gaps helps you describe specific features of the distribution, like most students read for 3 to 5 hours, with a gap between 5 and 8 hours. Next, we describe the center of the data, which is the value that best represents the entire set. In grade 6, we choose between the mean and the median. You can calculate both, but the shape of the distribution will tell you which one is the most appropriate summary statistic to use. The mean, or the average, is the best measure of center when the distribution is symmetric and doesn't have any strange outliers. Since the data is evenly spread out, the mean sits perfectly in the middle, balancing all the values. However, if there's a really high or really low number, the mean will be pulled toward that extreme value, making it less representative of the typical data. Because the mean is so sensitive to extreme values, the median is often a better choice when the data is skewed or has outliers. The median is just the middle number. Its position isn't pulled by a few high or low scores. If you had a skewed distribution, using the median gives a much more accurate picture of the typical value. Finally, we talk about the spread, which measures the variability of the data. Spread tells us how much the data points differ from the center. Are the numbers all really close together, or are they scattered widely? For grade 6, the main measure we use to quantify this spread is the range. The range is easy to calculate. You take the largest number in the data set, the maximum value, and subtract the smallest number, the minimum value. A big range means the data is inconsistent and highly variable, while a small range means the data is consistent and tightly packed. Let's apply these concepts to a small data set, 1, 2, 3, 4, 10. We have 5 numbers. Let's find the spread first. The maximum value is 10, and the minimum value is 1. The range is 10 minus 1, which equals 9. That's a relatively large range for such a small set. Now for the center of that set. 1, 2, 3, 4, 10. To find the mean, we sum the numbers. 1 plus 2 plus 3 plus 4 plus 10 totals 20. We divide 20 by the count, 5, to get a mean of 4. The median is the middle number, which is 3. Notice that the mean 4 is greater than the median 3. The fact that the mean 4 is greater than the median 3 is an important clue about the shape. The number 10 is an outlier, pulling the mean toward it. The distribution is skewed right. Because of that skew, the median of 3 is a better description of the typical value than the mean of 4. Let's look at a symmetric example. 2, 3, 4, 5, 6. The shape is symmetric because the numbers are evenly spaced around the middle. Since it's symmetric, we expect the mean and median to be the same. The range is 6 minus 2, which is 4. For this symmetric set, 2, 3, 4, 5, 6, let's confirm the center. The sum is 20. 20 divided by 5 gives us a mean of 4. The middle number, the median, is also 4. When the mean and median are the same, it confirms that the data is symmetric and that the mean of 4 is the best measure of center. The goal is to connect all three features. If someone tells you the average temperature last month was 25 degrees, that's great, but it's not the full story. If the distribution was symmetric, that mean of 25 is accurate. But if the range was 40 degrees, it means temperatures varied wildly, and the average doesn't tell you whether it was cold or hot on any given day. Center and spread must be discussed together. When you write a summary, you must put it into context. Suppose we looked at test scores and the dot plot was symmetric. A good summary would be, the distribution of math scores is symmetric. Therefore, the mean score of 85% is the best measure of center. The scores had a range of 20%, indicating low variability. Now look at a different example. House prices. Most are around 200,000, but there's one mansion at $1 million. The distribution is highly skewed right. We would say the distribution of house prices is skewed right due to an outlier. The median price of 200,000 is the most accurate center. The very large range shows high variability in the market. It's essential to use clear language and keep the data's context in mind. Don't just list numbers. Tell a story. Instead of saying the mean is 15, say the typical number of texts sent by a student is 15 texts per day. This connects the statistics back to the real-world question you asked in the first place. To wrap up, when you summarize a data distribution, follow a checklist. First, identify the shape, symmetric or skewed. Second, determine the best measure of center, mean for symmetric, median for skewed. Third, calculate the spread using the range. If you describe all three features in context, you've mastered summarizing data distributions.